Good morning, sir.
Good morning. So, shall we start? So, today, as we discussed in the last class, we will start with the first law of thermodynamics. Now, these are the contents. First, we will discuss the definition of what is the first law of thermodynamics. Then, we will just get an overview of Joule's experiment. Then, we will discuss about the this applications of first law of thermodynamics. This law is also known by non-flow processes. So under this first law, we will study constant pressure process, constant volume process, then constant temperature process, if we got enough time, and then we will discuss a few numericals or some illustrations. So first start with the definitions of first law. Now, according to various, you can say, studies, they have shown that the first law is the change in internal energy of a system between two equilibrium states. Two equilibrium states. Now, what does it mean? Ki whenever the system undergoes shifts from one state to another state, and we consider that both the states are in equilibrium, are equilibrium states, then the total amount of energy interaction is equal to the difference of heat transfer into the system and work done by the system. Now, the first law of thermodynamics is very much, you can say, governed by the Joule's experiment. Now, let us see what is the Joule experiment. So, Joule's experiment laid the foundation of the first law of thermodynamics. A system is designed to measure the temperature rise with the fall of weight. The system reaches its initial state by heat transfer across the system boundaries. Now, Joule has designed an apparatus, very simple apparatus, in which he tried to, you can say, translate the work into the heat. This is a pulley, and this he wound up the few threads on this pulley, and on the other side he suspended a some known amount of weight. Now, can you judge what will happen when he will this and this keep this weight to fall free from this height? Okay, what will happen in return? This it will try to revolve this fan. Now we can easily calculate the amount of work done by you can say mgh. It should be equal to the uh, heat energy translated into the system. अब यहाँ से heat energy कैसे आएगी? Now heat energy is generated due to the churning of water inside this system. Now when this fan revolves, जब ये रोटेट करेगा तो क्या करेगा, ये पानी को जो है चर्न करेगा, उसकी वजह से देर इज़ अ यू कैन से वेरी small amount of heat is produced or temperature is rise in the system. So in this way he tried to you can say calculate the what is the effect of work done on the system energy process. Constant pressure process is also known as isobaric process, in which the process in this process the pressure remains constant throughout the process. So then we can say that W is equal to pressure multiplied by V2 minus V1. Understand this process like this. Let us say there is a piston and cylinder arrangement. Now there is we put some weight on the piston so that it can put pressure on the gas which is enclosed inside the system. Now let us say we want to keep the pressure constant. Just we intend to keep this cylinder. So when the pressure increases, the piston will move upwards, and in during this process, the pressure will remain constant, because whatever there is a change in pressure, the piston will proportionally move back and forth in the similar fashion. So like for example, here we have supply some amount of heat. This is the initial coordinate P1, V1 and T1, and this is the final coordinates. Once the heat is supplied into the system, piston moves backwards, but still the pressure remains constant. So here we can write it as V1 into T1 equal to V2 into T2, because temperature and volume is constant, but pressure and temperature is varying and pressure is constant. So again we can write an equation for this. Now for a constant pressure, we assume that there is a piston and cylinder arrangement. We have put some weight on the piston, and there is a gas inside this closed system. Now when we supply some amount of heat here, that is P1, V1 and T1, since the piston is free to move, so piston will move in upward direction, so it will change its position just to keep the pressure constant. So here the final coordinates becomes P2, V2 and T2. So now if we can draw this pressure volume diagram, so what will we get? Here you can see that pressure is constant but volume is changing. So let us say first there was volume is V1, the coordinates of system coordinates were here, then the final volume becomes V2. So the system shifts from this point 1 to point 2. So here the pressure P1 is equal to P2 is equal to P constant, but volume is changing. So you can easily find out the area under this graph, this line, which is the shaded region, as I am showing here. So you can easily find out this area under this, you can say, shaded region. Now if we can find out this area, we can get the work done. So we can we will find the work done for a constant pressure process. Now work done is given by W is equal to 1 to 2 differential of P into dV, or this is equal to, since pressure is constant, P into V2 minus V1. Now we also know that PV is equal to MRT, so we can also write it as work done is equal to M into R into T2 minus T1. So this both equations we can use in this next section. Second is heat supplied. Now heat supplied Q is equal to, this is a heat supplied into the system. Now we know that whatever the heat is supplied, we can easily calculate it with the formula like mass of a gas into, since this is constant pressure process, mass into Cp into T2 minus T1, change in temperature. So this is the amount of heat transferred during the process 1 to 2. So this much amount of heat is transferred into the system. So similarly in next we can find out the change in internal energy. Change in internal energy, which is, we know that internal energy delta U is equal to U2 minus U1, or by first law equation, this thermodynamics has given us equation that total amount of heat energy is equal to W plus delta U. Now substituting the values for Q and W, we can find out the delta U. Now here Q is equal to, in terms of MRT, and this Q is M into Cp T2 minus T1 is equal to, and W is MR T2 minus T1, M into R T2 minus T1, and plus delta U. So from here we can say that delta U is equal to, you can also write down that delta U जो होता है change in internal energy is also having a unit of M, sorry, M into CV into T2 minus T1. इंटरनल एनर्जी के जब भी कैलकुलेट करना है उसमें हमेशा जो है स्पेसिफिक हीट एट कांस्टेंट वॉल्यूम यूज़ होती है उसमें, तो यहाँ पे इसकी वैल्यू भी हम पुट कर सकते हैं. तो अगेन वी कैन कैलकुलेट रीराइट दिस इक्वेशन एज एम सी पी टी टू माइनस टी वन इज इक्वल टू एम आर टी टू माइनस टी वन प्लस एम इंटू सी वी टी टू माइनस टी वन. So cancelling out the this common terms, we left with Cp is equal to R plus Cv. From here we get R is equal to Cp minus Cv. You have already, I think, know this relationship, very important relation. So this is, you have this constant pressure process. This is also known as non-flow process. चलो यहाँ तक समझ आ गया सबको.